choosing the disk subsystem for your data warehouse. Chances are, if you're in some form of IT or technology, you know what's going on with hard drives and SSDs, but have you actually thought about how they impact the performance of your SQL data warehouse? What we've drawn on the screen here is what looks like a classical stack of hard drives. These are the classic magnetic spinning disk hard drives. You've heard them all called different ways: hard drive, spinning disk, magnetic drives. That's what we're looking at here. And what we're talking about when we bring up these hard drives, we're talking about capacity. We're talking about the ability to store a bunch of data. That's what these things bring to the table. Now, they're a little bit slower, but they do come with different RPMs. You see, you can get drives whose disk revolves at a faster rate, and that way when the little magnetic arm comes over it and scans the disk or write the disk, it can read and write disk faster. And just about every time you jump up in RPMs, you also jump up in price. So that is a factor to bring in mind here, but the idea with spinning disks is we're trying to get more storage space. So if hard drives are the tool that gives us capacity but maybe at a slower speed, is there an alternative that could give us super fast speeds but maybe with the sacrificing of capacity? Of course there is. There's the solid state drive, and it does just that. It'll sacrifice some storage space. Maybe we can get a maximum size of 2 terabytes, but we can get much faster throughput, much faster bandwidth speed, such as megabytes or gigabytes per second of transfer speeds, and we'll have even better IOPS, which is a measurement of input and output operations that happen concurrently on a disk. But also with that comes a much higher cost. So that's the big trade-off here when we go from spinning magnetic disks to SSDs. We're going to be paying a lot more money. Now, with all that being said, there is a new entrant into the market right now that is NVMe storage. And it's basically an SSD that just connects in on a different bus. Let me bring up a browser and we can show you what I'm talking about. They look like this. They look like these little cards that just stick into the motherboard. And these are a type of SSD that operates at blazing fast speeds. Now, of course, with that comes even more trade-off between storage space, but we get much better performance then. So just know that now there's this NVMe, or non-volatile memory express, entrant into the marketplace. So SQL Server has a lot of files, and understanding where they're going to be laid out is super important. You don't want to put them all in just one place if you can help it. And that's why we're going to talk about where we're actually going to lay out our file system and how to build the array. So to start off with, SQL has the actual database files themselves. Those are MDFs and NDF files. They also have log files. This is where each transaction on the database files are going to be stored, and you don't necessarily want to put them in the same place. You may want to put them in a different area where speed is more beneficial depending on your backup strategy. You're also going to have the backups themselves, and those are of course going to be stored in BAK files, and those you probably want to put in a place where you can have more capacity so that you can have more robust backups. There's also the temp DB. This is basically database scratch space where we're going to be storing temporary transactions. It's basically a cache, and that's going to have performance implications if you're going to be making large transactions that need temporary space to happen. All of these decisions are going to be super specific to your environment. For instance, are your database files going to be gigantic and you need to go for capacity, or are they going to be in a nice size but we're going to query them very frequently so we need speed? You see, that's where the hard drive versus SSD comes into play. And once you've got that decided, then we actually have to talk about the physical enclosures of your hard drives and SSDs too. Of course, you could just have them directly connected straight into the server, and in that case, SQL Server will just access the drives directly. But maybe a better solution to get more storage is to buy a unit like this one that you see here, a storage unit that holds multiple hard drives, and allow that server to directly access that unit over something maybe like a fiber cable or a SCSI cable. And this is called directly attached storage, or DAS. And that is a cost-effective solution that can really help you expand the amount of storage and the types of storage that you can hold. But is that the most common implementation of storage? No. The most common implementation of storage is to create a network of dedicated storage using something called a SAN, or a storage area network. And this is kind of like what the diagram shows. It's a gigantic pool of disks and storage that devices can connect to over the network to get the storage to show up. Usually a protocol like iSCSI. And iSCSI essentially makes these virtual drives sitting here on this SAN show up as locally attached storage here on these servers. And in this particular instance, you can get SANs that are just magnetic hard drives, SANs that are all flash storage, and SANs that are a mix of both, or even SANs that are NVMe now. This is a great solution because it makes you super robust in how you can configure your different disk arrays and different backup options, deduplication, all sorts of things. But the problem with it is it's going to be very expensive because you have to buy the unit and the networking portions to implement it. And lastly, there is an implementation that does away with this model entirely called hyper-converged infrastructure. And what that means is these servers here all pool their locally attached storage together, and it shows up to the operating system as if it had connected to the SAN. That way, if this machine had 8 drives, and this machine had 8 drives, and this machine had 8 drives, all 24 drives will show up to the operating system cluster as one virtual SAN. This is implemented using something like Microsoft Storage Spaces Direct, VMware vSAN, or other retailers like Nutanix have implementations for this. In this nugget, we covered the different types of hard drive medias available to you, whether it's spinning disk, solid state drives, or NVMe. We then talked about the file layout of SQL Server, and we have to make the choice of which types of media we're going to put each of these files on. And lastly, we talked about the actual infrastructure layout of how we can connect to our storage subsystem. I hope this has been informative for you, and I'd like to thank you for viewing.